To analyze data, we need to know what is data. Data is a collection of facts. The facts can be numbers, words, some measurements, or some observations, or they can be just descriptions. The data can be four types. There are nominal data, ordinal data, interval data, and ratio data. When we talk about nominal data, this is kind of data that we cannot quantify. That is, we cannot measure their distance, we cannot order them. Example like gender, male, female, or hair color, brown, black, gray, etc. We cannot say brown hair is better than gray hair or gray hair is better than brown hair. It is just their label. So because we cannot calculate their distance, we cannot order them, therefore we cannot have their average, but we can calculate their mood. For example, we can say what is the most common hair color in a population. Next data type is ordinal. Ordinal data is kind of data that we can order, but we don't know the distance between them, or we don't know the interval between them. Some examples are like happy, very happy, unhappy, so on. We know that very happy is better than happy, but we don't know how much more happy makes it very happy. Another example can be ratings of movie or some products. Like we give 1 to 5 stars. We know that 5 star is better than 4 star, but we don't know how much 5 star is better than 4 star. Because we cannot calculate their interval, we cannot calculate their average, but we can calculate their mood and median. Next, interval data. For interval data, we can order them. We can have their interval, but we don't have their absolute zero. So one example is temperature in Celsius degree. 0 degree Celsius doesn't mean there is no temperature, it just means the temperature is low. So for example, 0 degree Celsius temperature actually means 32 degree in Fahrenheit. So obviously 32 degree Fahrenheit is not zero, and because we cannot have their absolute zero, we cannot calculate that ratio. So for example, we cannot say that 20 degrees Celsius is twice hotter than 10 degrees Celsius. To clarify it, 10 degrees Celsius equals 42 degree in Fahrenheit, and 20 degrees Celsius is 52 degree in Fahrenheit. So obviously 52 degree Fahrenheit is not twice as much as 42 degrees Fahrenheit. Then ratio data. Ratio data is kind of data that has order, interval, and absolute zero. Therefore, we can calculate their mean, average, and we can calculate their ratio. So for example, we can say 10 apple is twice as much as 5 apple. Another example can be temperature in Kelvin. So 0 Kelvin means absolutely no temperature. That means we can say 10 Kelvin is twice hotter than 5 Kelvin. Data can come in many formats. The common type of format used for data analysis is two-dimensional table. Along the top of the table, we have attributes that records different measurements. So for example, if we are collecting data about a population, then the columns can have measurements like age, gender, nationality, residential address, and so on. And each row of the table stores individual instances or samples of the population. For example, the gender, age, nationality, and residential address of a specific person is recorded in a row. So we can have as many records or as many rows we want, and the columns are sometimes called features or variables as well. Sometimes along with these columns we can have another extra column at the right of the table that actually records decision or outcome of these instances. So for example, if we are recording the population with high medical risk, we can have a column at the right part of the table that will record whether an individual person has high medical risk or not. Now we'll see an example. So for this example, we will use Python. I use Python partially because my background is programming, and the reason is Python is free, open source. It is very popular in data science community. You can also use R or MATLAB. For this example, we will use a sample data set of housing prices. and the data set is organized in a tabular form, that is a two-dimensional table. And for the processing or for the analysis, we will use pandas as a way to represent and manipulate our data. Panda is very popular for analysis, and for using this panda we need to first we also import matplotlib to show some visualization. So first we import these two libraries. Then we load our sample dataset and store it to a variable called df. And for reading the data, we use pandas function or method read underscore csv. We want to see the head part of the data, that is first 5 rows from the data. We can also see 10 or whatever number of first rows from the data set. So to do that, we use df.head and we mention how many rows we want to see. So here is 5 rows, and we see that the data frame has 1 2 3 4 5 6 columns. And first one is living space, that is what is the size of living space, and then how many beds in the house. Then we have jeep. Jeep means the geographical location is identified by jeep here. And then we have year, what is the year when the house was sold. And then we have quality of the house, and finally we have price of the house. In a predictive manner, we can think that we can use a living space, beds, jeep, year and quality to predict housing price. So we learn from the first instances and then we can predict future housing price. In this data frame we have several types of data. For example, living space, it is a ratio data, beds is a ratio data, and then jeep is a nominal data, because even though it is represented like a numerical data, but this jeep value specify or label a geographical area, so that's why we can say it is a nominal data. Year, we can order it, so we can say it is ordinal data. Quality also we can sort quality high low, so it is a ordinal data again. And the price is a ratio data. And so we have several types of data here. Now let us do some investigation and processing of this data set. So if we want to see first 5 rows, then we can see first 5 rows. If we say okay, start from 2, then we can say start from 2 to 5. Then we can see index 2 to 5, that is 3 rows. If we want to see 5 random rows from the dataset, we can actually use df.sample and we mention how many rows we want to see. So we can see 5 random rows. If we want to see a specific row, we can use df.ilog and the index of that specific row, and that will give us the specific row. So on the left column, for example, if you see here on the very left column, it is index and rest of them are like different features in the data set. Then if we want to see a specific value in the second row, for example, if we want to see the price in the second row, then we can use df.ilog and then index of the row and then column name price. If we want to see the names of the columns and the table, we can use df.columns, so that will show us all the column names. If we want to see all the prices in the dataset, or for example if we want to see all the values in a column, we need to say df and then in the third bracket we need to mention the name of the column that will show us all the values in that column. If we want to sort values or sort the rows in the table using a specific column, we can use df.sort underscore values and then by which column. So we want to sort here by the column year, so we say okay, by equal year. So now if we execute this command, we see that we have all the rows sorted in the ascending values of years. If we want to show our housing price in the ascending order of years using a bar graph, we can use df.plot.bar, and then we need to mention what will be the x-axis. So our x-axis will be year and our y-axis will be price, and rotation is actually for x-axis labels we can rotate it 45-degree angle so that it shows better, like it is readable. So what I mean is this. So here all the x values are 45-degree slanted, so it is easy to see them, and we can see that housing price varies from year to year. And if we want to see some statistics of columns, so for example, if you want to see some common statistics of living space, beds, and price, we can mention them in a vector and then use it with df and third bracket and then the vector, and then we can say dot describe. That will show us the basic statistics of these three columns. So it shows count, that means how many instances, then mean, what is the average or mean value for this column, then standard deviation, and then minimum value, what is the minimum value in that column, and then 25%, that means first quartile of the distribution, and then second quartile, that means 50% of the distribution, and 75% of the distribution, that is third quartile. And finally we have the maximum value in that column. If we want to see the basic statistics for a qualitative or nominal value, we can do that. And if we use describe, actually describe can automatically identify a column if the values are like text or something like that, then it assumes that the values are in nominal or qualitative form, so it will give us different statistics like count, where so there are 20 rows, and then there are 3 unique values in this column, and then the most frequent value in this column is high, and the frequency of high is 8, that is it occurred 8 times in the column. And now if we want to see some correlation among the columns, we can use some Pearson correlation or some other correlation. So for showing correlation, we use df.correlation. What method will be used to find this correlation? So here we are using Pearson, so we can see that it shows Pearson values for each column against all the other columns. So we can see that housing price is highly correlated with living space, and another one is like living space is also correlated with beds, and so on. If we want to show them visually, we can do that. In this example, we can use a very user-friendly library called Seaborn. So we can use matplotlib as well, but Seaborn is relatively easy to use, so here I am using Seaborn. So if we use Seaborn to visualize this correlation, we can see that high correlation means darker values. So positive high correlation is red dark values, and negative high correlation is dark blue. We can see that here living space and housing price has really a high correlation. Also living space and beds has high correlation, but in the diagonal we see that it is really highly correlated. All the values are 1. This is because it finds the correlation with itself. So for example, what is the correlation of living space versus living space? So it is itself, so that's why the correlation is maximum 1. For other columns the value is less than 1.